Well, hello everyone. Let's see what we did in Target 1B. So the very first thing we took a look at is multiplying polynomials. So let's do it. What we're really doing here is applying the distributive property, which means multiplying. So let's distribute. The first thing I'm going to distribute is that 2x. 2x times 3x gives us 6x squared. 2x times negative 5 is negative 10x. Next, I'm going to take that negative 3 and distribute it as well. Oh, I should have used a different color. Let's do that real quick. Bear with me. Thank you, thank you. All right. Negative 3 times 3x is negative 9x. Negative 3 times negative 5 is positive 15. We just have one last step left, and that is to combine like terms, which happen to be right in the middle. So we have 6x squared minus 19x plus 15 as our final answer. Let's try this next one. Now this next one's probably one of my biggest pet peeves. There's just one big no-no here. We cannot distribute that 2. I know it's so tempting, but that's a big no-no. This is what that 2, that exponent, is really telling us. It's telling us that we have 2 of these parentheses, not just 1. All right, well, now that we wrote out 2 of them, let's multiply. Negative 2x times negative 2x is positive 4x squared. Negative 2x times positive 3 is negative 6x. All right, one more time with this 3. 3 times negative 2x, negative 6x. 3 times positive 3 is positive 9. Let's combine those like terms. 4x squared minus 12x. Oh, did you see that? Wasn't that crazy? How did that? Oh my goodness. All right, let's try that again. That should be a 12x plus 9. All right, fantastic. Next, we looked at multiplying binomials by trinomials. It's just going to look longer, but it really is the same idea as these two. All right, so let's check it out. I'm going to zoom in. Now, what I like to do when I have more than just a binomial and another binomial is I like to kind of organize things vertically. And you see what I mean in a second. This is just a personal preference. Maybe you'll enjoy it too and start using it. Or you'll just be like, whatever, Ms. Guman, I'm just going to keep doing it my way. Whichever you choose, fine with me. All right, so let's distribute that 2x first. 2x times 3x squared is 6x to the power of 3. Don't forget that that x has a power of 1. X squared has a power of 2. When you add them, we get 3. 2x times negative 6x is negative 12x. 2x times positive 12x squared, my bad. 2x times positive 2, that's 4x. All right, let's do the 3. I'm going to distribute it all the way around. 3 times 3x squared is going to be 9x squared. And this is where that vertical comes in. I'm just pairing things up. 3 times negative 6x is negative 18x. And 3 times 2 is 6. Could I have written it all in a single line like I did the other problems? Sure. But my binomial and my trinomial are both in standard form, which means this is going to work out. I like it. It feels more organized to me. I don't know why that 3 did not turn out like a 3. Well, let's add. There's nothing to add the 6x to the third, so it just remains 6x to the third. Negative 12 and 9 give us negative 3x squareds. 4 and negative 18 is negative 14x's, and then the 6 just stays a 6. When we're multiplying, generally speaking, most of the time actually, your first and last terms are going to stay by themselves. All right, so that's multiplying polynomials. If you have questions about that, make sure to ask myself or your teacher about it. The second part of target 1b, I left myself too much space, but that's fine. The second part is writing equations based on zeros. Now, I'd like to remind you that zeros are x, so that was supposed to be an arrow. It turned out so ugly, we're going to try again. Zeros are x-intercepts, which are also roots. When we're writing equations, we call them roots, technically. And roots are always written as x minus r being the root. So, let's write some equations using these roots. Now, we have to watch out for two things. We have to watch out for even and odd powered roots. And we'll talk about that as we go through it. Okay. Now, let's take a look at this first graph. And let's mark the zeros. So I'm going to zoom in all the way so we can see very clearly where all those zeros are. Ooh, excuse me. Okay, so let's get to it. There's one right there, right here, and right here. Now notice all of these zeros are crossing through that line. So it crosses at 0, then it crosses back down at 3, then it crosses back up at 5. When a 0 crosses like that, that means it's odd. So the power is odd, giving us the smallest power available, which is 1. Now, I don't know if these were odd powers like 3, 5, 7, 11. I don't know. But this is the closest guess we can make from this graph. Okay. So first we have 0. So my first root is x minus 0. Then I have a 3, x minus 3, and then a 5, x minus 5. Now, it might look a little silly to you, and I really hope it does, that I wrote x minus 0. We don't usually write that. We don't need to write subtracting a 0. When you subtract by a 0, nothing changes, right? So, let's simplify that just a little bit. Let's write this as f of x equals x, and then x minus 3 and x minus 5. Now that looks way cleaner, way nicer. All right, that's it. We're done with that one. Not too bad, right? Let's take a look at this next one too. All right, I already see a difference here. You see this 0 right there at -4? That is not crossing. Well, let's mark that 0. Here is a 0 at -4, and there's one more 0 at 7. Okay, so what does that mean to us? Well, when we have a 0 like this that just touches 4 and then kind of bounces back, well, those are even-powered zeros. So that could be a square, it could be a power to the 4th, to the 6th, I don't know, just by looking at this graph. But we can safely assume the smallest power that could possibly happen here is a 2, because 2 is the smallest even number. So that's what I am going to assign that root. All right, so f of x equals. Now I have x minus, and the root here is -4. I'm going to square it because it's touching. And I have x minus 7. Now, x minus -4 looks kind of ugly. So let's simplify that a little bit. We don't usually write minus minus. When we subtract a negative, it becomes a plus sign. And that is as far as we can go. So once again, just to reiterate, if we're crossing the x-axis, it's an odd root, which smallest power is 1. And when we are bouncing off of that x-axis like it did in the -4 here, it's an even root, and we give it the smallest even number, which is a 2. All right, fantastic. If you have any questions about writing equations based on zeros, or even multiplying polynomials, please make sure to ask myself or your teachers for some extra help. All right, have a wonderful rest of whatever day it is for you. Bye!